13.3 is going to take us into the trig functions of general angles. Now, knowing about our unit circle and being able to use a unit circle is one thing, but we know that life is not always going to line circles up on unit circles perfectly for us. So we need a way to be able to use these ideas of cosine and sine and our xy coordinates on just regular old angles no matter where they are. So basically when this r is not 1, when it's not on the unit circle. So this says let theta be an angle in standard position and let p of xy be a point on the terminal side of theta. So we're going back to our initial side, our terminal side, and a point xy somewhere on the terminal side. If we use the Pythagorean theorem, which is closely related to the distance formula, we can find this length of r from the origin to the point with this formula right here. Then what happens is all of these trig functions can be related to the xy coordinates and that distance r. Now you know this row is our main row, this row is our reciprocals of the row above it. If again you think about this in terms of a triangle, of a right triangle, even if I draw it over here on the reference angle, this is my x, how much I went over, this is my y, my hypotenuse is that r. Look at what the sine is. The sine, reference angle, is opposite over hypotenuse. And the x and the y and the r are all taking those positions. So it says find all 6 of a point on the terminal side of 8, negative 15. Well, where's 8, negative 15? Over 8, down negative 15. It's somewhere over here. So my angle, initial side, terminal side, I'm looking at theta like that. So the first thing I need to do is find r. Well, r is equal to x squared plus y squared, which is the square root of 64 plus 225, which equals the square root of 289, which is 17. So now it's a matter of the sine of theta is y, negative 15 over r. Cosine of theta is x, 8 over r. Tangent of theta is opposite over adjacent. It is negative 15 y over x. Once you have those 4, then to do the cosecant of theta is simply the reciprocal of sine, 17 over negative 15. Cosine becomes secant, which is 17 over 8, and tangent becomes cotangent, which is 8 over negative 15. Now here, when it asks us to find exactly 3, we're talking about the big 3, sine, cosine, tangent. If I'm looking at that point at 5, negative 12, it lives somewhere down there. Again, I'm looking at this angle theta. I need to find r. r is equal to the square root of 5 squared plus negative 12 squared, which is equal to the square root of 25 plus 144, equal to the square root of 169. r is 13. So, sine of this theta angle is y over r, negative 12 over 13. Cosine of theta is equal to x over r, 5 over 13. Tangent of theta is equal to y over x, negative 12 over 5. this is just summing up kind of those major angles of the crosshairs at 0, 360, at 90, at 180, and at 270. In order to figure these trig ratios out, you really want to think it's easiest to think about R being 1 and using your unit circle and the work you've done with your unit circle to figure those values out. Now, reference angles. This is the important concept that we use when we are working with our unit circle. And this theta r, theta subscript r, is the reference angle. What happens is that mirror image, that quadrant 1 repeat all the way around, has to do with either subtracting or adding to the x-axis. So here I'm going to subtract, here I'm going to add, here I'm going to subtract. And we know that this is 180 or pi, 180 or pi, and here we're at 2 pi or 360 as we back up and subtract to find our reference angles, or go ahead and, even though this looks weird, we're going to add to find our reference angles. So what happens? Where is 160? Well, 160 is about right there. Its reference angle is this one, and the reference angle is 20. If we're at 180, we back up 20. So if we looked at the sine and the cosine of 20, they would be directly related to the sine and cosine of 160. Sine would be the same, cosine would be the opposite sign. Now, negative 110 means I need to go clockwise. Initial side, 90 plus a little bit more. So how much more? Well, my reference angle is here. How do I get from 180 to that spot? This was negative 110, so I went to 90 plus 20 more, plus 20 more. So what's left here, theta r, is 70. And so if you look at the sine and the cosine of 70, they're going to be the exact same values of negative 110, except the opposite signs. If I do 270, that means I would go all the way around. There's 270, 275 is right there. Here's theta r, and from 360 back to this point, or to finish off, think about this in terms of 90 here, theta r is going to be 85 degrees. If I look at and think about doing this in terms of radians, nothing really changes. Remember, this is pi, so if I'm dealing with fourths, this is 4 pi over 4. Here's my initial side. This, going backwards, would really be pi over 2. So that means, which is the same as 2 pi over 4. So that means that somewhere about yay is negative 3 pi over 4. So my theta r, my reference angle, is pi over 4. So it's that same concept we used when we built our unit circle. So if we look at some examples, it says find the exact values. So this is unit circle work. So where is the cosine of negative 60? That's right down here. Well, I know that the cosine of negative 60, that angle is in quadrant 4, which means that the cosine is positive, means it's exactly the same as a 60-degree angle, and that means that the cosine is 1/2. 5 pi over 4, remember 4 pi over 4, so I'm going to go all the way around plus 1/2. My reference angle here is pi over 4. Pi over 4 has a cosine value of square root of 2 over 2, but in quadrant 3, cosine is a negative, so the cosine of 5 pi over 4 is negative square root of 2 over 2. Negative 150, where is that angle? That angle is right here. What is its reference angle? Its reference angle is 30. So what's the cosine of 30? Well, that happens to be the square root of 3 over 2, but over here in quadrant 3, we know that cosine is negative. So the cosine of negative 150 is negative square root of 3 over 2. Cotangent, excuse me. So cosine is that, negative. If we're finding cotangent, the tangent of 30, do a little extra work there, the tangent of 30 is a square root of 3 over 3. That's in quadrant 1. In quadrant 3, the tangent is also positive. Cotangent is the reciprocal, so the cotangent of 30 is 3 over square root of 3. I have to multiply top and bottom by square root of 3 over square root of 3. And so I end up with 3 square roots of 3 over 3. Those cancel, and I end up with the square root of 3. Our last one here is asking us about the cosecant of negative 2 pi over 3. So first we're going to worry about where negative 2 pi over 3 is. Well, it happens to be over here. That means the reference angle is pi over 3. So cosecant is actually related to the sine. So let's focus on the sine first. The sine of pi over 3 happens to be square root of 3 over 2. In quadrant 3, the sign happens to be negative, which means the cosecant is also negative. The cosecant of pi over 3 happens to be 2 over the square root of 3. Can't leave that, so I've got 2 radical 3 over 3. Since I'm in the third quadrant with this angle, the cosecant is negative 2 radical 3 over 3. And that's all there is to lesson 13.3.